You take all the parallel parts and do parallel first. 1 over 30 plus 1 over 30 plus 1 over 30. What is the total of 1 over 30, 1 over 30, 1 over 30? Or 3 over 30, or 3 over 30, and then you have to take the reciprocal of that number, because you don't want 1 over the total, you want the total. What's 30 divided by 3? Okay, so my total for this whole thing is 10 ohms. So the total resistance for the circuit is 20 ohms, which is the series part. All the electrons have to go through there, plus 10 ohms, which is a total resistance of 30 ohms. That is the number that I will use to solve for the total current. So if I have 120 volts and 30 ohms of resistance, you should get a total current equivalent to 4 amps. Just use Ohm's law, V equals I times R, to solve for that portion. So let's start with the 20 ohm resistor. I know that a total of 4 amps of current goes through the circuit. Does all the current have to go through the 20 ohms? Yes. So the I through this is going to be equal to 4 amps. And I know my R, and I now know my I, so I can solve for V. V equals I times R. So 4 times 20 is 80. 80 volts is what I spend here. When I go and I look at my circuit, I should notice that now I have 3 options. If I choose branch 1, branch 2, or branch 3, I will have to spend all the remaining voltage at any one of those branches. So I could do a subtraction problem. So I start with 120 volts and I end up with spending 80. So how much voltage will I have to spend at any one of those lines? What's 120 minus 80? So each line I must spend 40 volts. And I'm putting this in the big line box here, not the individual, because I'll spend a different amount at each of those resistors. But my voltage across each of these lines is 40 volts. So we can do Ohm's law on this first branch and be totally done and know exactly what the resistance is for this whole thing. So V equals I times R. I have 30 ohms of resistance, 40 volts are spent across this. What would be the total current across this first resistor? Whatever 40 divided by 3 is. 1.3 amps of current. Okay, it's the same across the other 2 branches, the same equation for the totals. So I have 1.3 amps of current here, and I have 1.3 amps of current here as well. From this point forward, now I can start to splitting it up and solving for each resistor individually. So 5 ohm, 10 ohm, and 15 ohm, I made columns down here, and I'm going to just keep my information. Do all of the does all the current have to go through each of the resistors if they chose that second branch? Yes, they all have to do that. So I can fill in very easily 1.3 amps here, 1.3 amps here, and 1.3 amps here. They're all the same because this entire circuit, if you look back up at our circuit here, it's one straight line. So if they choose this path to go down, all the cars have to go through all 3 resistors.
Now you can use Ohm's law for each one of those.
So I can go back down here and I can use Ohm's law for each one of those and figure out how much voltage I will spend at each of those particular locations. V equals I times R. So for this 10 ohm resistor, my voltage should equal 13 volts.
So the top one's the total?
The top box here, these are all totals for the whole line. Okay, so that's the total for the entire line. So the middle one, the 10 ohm resistor, should have 13 volts. The 5 ohm resistor should have 6.5 volts. And the 15 ohm resistor should have 19.5 volts. these should add up to be approximately 40 volts. If it's not exactly perfect, it's probably because we rounded differently. The 10 and the 40 ohm together, and then the 22 ohm. I have 1.3 amps of current that has to go down this path. Of all of these resistors, which one will have all the cars going through it? The 22. Only the 22 will have all cars going through it. So the current here has to be 1.3 amps. I can then solve for how much voltage I spend at that particular resistor. Again, I'm using Ohm's law, and I figure out that I spend at the 22 ohm resistor, I spend a voltage equal to 28.6 volts. I did that one first because that allows me then to think about the 10 and the 40 as one unit together. If I already spent 28.6 volts at the 22 ohm resistor, then I have to spend the remaining voltage at those two. Recall that those are in parallel with one another. So if I choose to go through the 40 ohm resistor, I'll go through the 40 and then through the 22. If I choose to go through the 10, I will go through the 10 and then the 22. So I have to spend the rest of my voltage, which should be a voltage remaining of 10.4 and 10.4 at both of those locations. From that point, I can then solve for current. So I have voltage, I have resistance at each of those. I will spend a different amount of current at each. I would expect that I would spend, or I would have more cars being sent towards the 10, which I indeed do when I solve for that, and fewer cars sending themselves towards the 40 ohm, which again, if you solve, I only have 0.3 amps of current there. Because recall, you'd like to go to the one that's less. Oh, you're right, 11.4. Apologize.